this problem, we have a CD with a radius of 0.1 meters and a mass of 0.025 kilograms, and it's rotating at 3.1 radians per second. The CD stops in 7 seconds when it is turned off. First, we want to find out what is the angular acceleration of the CD. Then we want to find what is the moment of inertia of the CD, given the formula that the moment of inertia is 1/2 mr squared. And then finally, how much torque is applied to stop the CD. As always, we start by drawing a picture of what's going on. We have a CD, and then we have it that it's rotating or spinning. We're going to write down our givens. We have a radius of 0.1 meter. We have a mass of 0.025 kilograms. We have that it's rotating at 3.1 meters per second. Radians per second. That is an angular speed, since it's in radians, so that's a Greek letter omega. And it says that the CD stops in 7 seconds. Since it stops, we know that the final angular speed is 0. That means that this is the initial angular speed. In part 1, we want to find out what is the angular acceleration. So to solve for the angular acceleration, we know that it starts at 3.1 radians per second. It goes to a final speed of 0 in a time of 7 seconds. So we want to look for a formula that has initial and final angular speed, time, and of course angular acceleration. We find that formula in the form of omega f equals omega I plus alpha times t. We then substitute our numbers. Instead of omega f, we have 0. Instead of omega I, we have 3.1. We're solving for alpha, and our time is 7 seconds. We solve for angular acceleration, and we get an answer of negative 0.443 radians per second squared. For part B, we want to find out what is the moment of inertia. Now we're given the formula of moment of inertia in the problem itself, and the formula is 1/2 the mass times the radius squared. We know that the mass here is 0.025 kilograms, and the radius is 0.1 meter. We're going to square only the radius. Only the 0.1 gets squared. As we solve, this gives us an answer of 0.000125, and the units are a kilogram times meter squared. Now your calculator may give it in scientific notation. Scientific notation would be 1.25 times 10 to the negative 4. The very final thing we're going to solve for is how much torque is applied to stop the CD. And there's a reason that A and B were in there, because we're going to use this angular acceleration and the moment of inertia to solve for the torque. We're going to multiply the two together. This will give us the net torque acting on the CD to stop it. Okay, as we solve here, we get an answer of negative 5.54 times 10 to the negative 5th Newton meters. Now that's in scientific notation. If you prefer standard notation, it would be negative 0.000554 Newton meters. Now the reason for the negative is simply that we are slowing the CD down. So it's working in the opposite direction of the initial angular speed.